Hello, my name is John Kelly, and this is the Weber Auto YouTube channel. This is the fourth episode on the evolution of the Toyota Prius hybrid transaxle. As you can see, sitting beside me here is a 2017 Toyota Prius Prime. And then on the hoist, back here behind me, we have a 2017 Prius Eco. The Prius behind me on the hoist and this Prius Prime here are the fourth generation Toyota Prius here in the United States. They both use the P610 hybrid electric transaxle, and there are a few differences between the two, since the Prius Prime has an electric vehicle or EV mode only, where the Prius Eco behind me does not have much of an EV mode. So let's go take a look at this new P610 hybrid transaxle. The P610 is a totally different design than the previous Prius hybrid transaxles. But as I mentioned in the introductory video to this series, to really understand how this transaxle works, you need to go back and look at those other transaxles and how they worked and how they evolved, because you can pretty much see pieces and ideas from every one of those transaxles in this one right here. Now this transaxle, as I mentioned, is the P610. If you look right here on the side of the case, it says P610. There's a 3-digit code, the 1NM right there. This is the driver's side case of the transaxle, and this would be the front of the transaxle. This transaxle is part of the Toyota New Global Architecture, the TNGA system. And what that system is they are trying to make everything more efficient, smaller, compact, reduce weight. This transaxle is the second lightest Prius transaxle ever made at 179 pounds. The only one that's lighter weight than this is the Prius C transaxle, which has considerably less power at 176 pounds, so only 3 pounds lighter. This transaxle is 51 millimeters narrower in the vehicle than the P410 transaxle that was used in the third generation Prius. So it's a smaller package, it's lighter weight, and as it turns out, it has more power than the previous transaxles had in the past. So let's take a look at a few things here. First, this is a fully assembled transaxle. We are going to totally disassemble it, look at the parts, the components, talk about the theory of operation, and show you that even though it's a different design, it still works just like the previous model transaxle, the P410. It's just everything is arranged in a different location. So here on the side of the case, we still have the oil pump on the side case, but it's inside the case now rather than externally like on previous transmissions. We have an electrical connector right here where there are two resolvers. We have our MG1 motor, that's our starter motor for the engine, and our generator down here in this section of the transaxle. Then up here we have MG2, which is our traction motor that propels the vehicle down the road. So they're offset of each other. This is called a parallel axis transmission, and it's very similar to the Ford hybrid transaxles and the 2017 Chrysler Pacifica, the SI-eVT, the single input electronic variable transaxle. They all have the same parallel design here. But as I mentioned in the introductory video, this transaxle is highly refined compared to the previous Ford ones. Now Ford for 2017 has a new one that I have not seen yet, and I read that it has a new highly refined motor system, so maybe they've done the same thing. I have seen inside the Chrysler Pacifica one, and it's a real nice transaxle, very powerful transaxle for a minivan. This is got all the power we need for a small Prius, but you're never going to see this in a minivan. You might see a larger version of it, but this is definitely a small car transaxle. All right, another thing that's unique here on this transaxle, if you look right here, we have all 6 3-phase cables for both MG1 and MG2 coming up, and they're just these little tiny diameter wires, and the inverter converter sits right here on top of the transaxle. Let me grab that inverter. So even this inverter converter design, this system is about 15 pounds lighter than the 3rd generation Prius inverter converter. We have the inverter portion that does the AC to DC conversions and the DC to AC conversions, and then down in the bottom we have the DC to DC conversion that takes place. So that's the inverter in the top, convert DC to DC converter in the bottom. So this just sits right up here, just like that, in the vehicle, and you can see under the hood, you can see this black cover sitting right here. There's a label right here that shows, or that you can see under the hood, and all of this is what's underneath it. So it has a low center of gravity in the vehicle, which makes the vehicle handle better also. But that's the new inverter converter. It has an electrical connection just right here on the side. All the bolts for the 3-phase cables go through there, and there's a weather-tight shield that goes over it. A couple of coolant hoses that hook to it to keep it cool also. But we won't concentrate on the inverter converter in this video. Maybe later on I'll do videos on the inverter converters. All right, if we rotate the transaxle around to the front view here, you can see we have an electronic shift actuator, just like a lot of the previous Prius transaxles. We have something new to this P610 transaxle, and that is a heat exchanger that's external to the transmission. Now, Toyota has done the heat exchanger that's external to transmissions on regular planetary gear set style transmissions, but up to this point, on the other Prius transaxles, we've had coolant that actually ran through passages in the transaxle itself. That's no longer the case. The oil pump on the side cover here will pump fluid up to the heat exchanger right here, where we have coolant from the radiator coming in here, and then it goes through, absorbs the heat from the hot transmission fluid, and then it goes out to the electric water pump and the inverter converter and back through the radiator and cycles back in here. The transmission fluid that gets cooled down then goes up to the top of the transaxle right here, where it goes through and splits apart and goes to the stator assemblies of both the MG1 and the MG2 motors and cools those stator assemblies. And we'll take a look at how that happens here in just a little bit, and what those stators look like. If we look at the engine side of the transaxle, you can see the clutch damper assembly, as Toyota service information calls it. The damper assembly looks very much like the previous transaxle ones. It simply splines to the transmission input shaft, which is directly connected to the planet carrier of the power split device, just like all previous Toyota hybrid transaxles. The clutch damper assembly bolts right to the flywheel. I've got an alignment mark right here where I took it apart. There's 6 bolts that hold it to the flywheel, and it rotates as one assembly. Now, if you have the Prius Prime here in the United States, or the Prius plug-in elsewhere, then in between, sandwiched in between the back of the flywheel and the crankshaft where the flywheel bolts, is a special one-way sprag clutch. And a sprag clutch will allow the crankshaft to rotate one direction but not the other. So the Prius Prime uses that because this transaxle in the Prius Prime will use MG1 to help propel the vehicle down the road. But it can't do that unless we can prevent the engine from spinning backwards, and it does that with this one-way sprag clutch. If we keep turning the transaxle here, in the bottom of the transaxle case is the drain plug to drain the Toyota World Standard transmission fluid. If you need to check the transmission fluid level in your Prius, you just remove this plug. The engine does not have to be running. Make sure your vehicle's on a level surface. If fluid comes out, too much fluid was in it. If no fluid comes out, either it's at the right level or it's low. Now, the instructions and service information say it can be a few millimeters lower than the plug here. As a matter of fact, on this transaxle, it can be 8 millimeters lower than the plug and still be in the acceptable range. So you can add fluid back in here until it's up to the top and flowing back out. Let it come out until it slows down to a real slow drip, and then you're full. There's also a fill plug right up here on the top. If you use this plug to add fluid, don't take this plug out until you've cleaned this whole area off, because dirt and crud might get down inside of the transaxle. It's better to use this one here on the side. There's an aluminum gasket, and these bolts need to be torqued in place. That gasket typically is not reusable. You're supposed to replace it and then torque it to specifications to keep it from leaking. All right, as we continue turning on the side here, looks like nothing to see on that side, and we're back to the side of the transaxle where we started. All right, well, let's start taking this thing apart. To disassemble this transaxle, there are 3 case pieces that can be disassembled. You've got your rear cover, and do not take that off until last. The bell housing portion, which is this section forward, is what we're going to take off first, and so we're going to lay the transaxle on its side, and then that allows us to get to the final drive gear and the counter gear, and see the gears that both MG1 and MG2 connect to. If we take off this rear cover, then we can see the stator assemblies, the rotors, the resolvers, the oil pump, and so on. Normally, that's not a serviceable area. You can't buy parts for anything in there. You can buy that half of the case and replace it on previous transaxles. Right now, I don't know what you can buy other than the whole transmission on this new of a transmission. But I suspect if it's just like any of their previous transaxles, that pretty soon you'll be able to buy pieces. Pretty soon you'll be able to buy service pieces for it. All right, so let's lay this transaxle on its... We're going to lay it on its back, but there's a pressure tap plug right here in the back that I'm going to take out because the whole weight of the transaxle will lay on that plug if I don't take it out. When I do take it out, then it lays on this rib right here, and it won't hurt anything. So I'm just going to set that off to the side. Now, I've had this transaxle apart already and back together, exploring, cleaning, labeling everything. So these bolts are all loose. Normally, they would obviously be torqued. You need to be careful with how you treat hybrid transaxles and any transaxle for that matter, because there's electrical connectors and other small breakable parts on there that you don't want to break. They may not be available to purchase or could be quite expensive or timely before you could get them again. All right, here on the front of the transaxle, we've got to remove our heat exchanger and our oil cooler pipes to get this bell housing off. When I disassemble a transmission, especially one I've never been into before, I make sure that I bag up all the parts that go together in the same bag so that I can stay organized. There's a banjo bolt on the top of the transaxle here where the cool fluid comes in, where it goes directly to the stator assemblies to cool them. Okay, so there's the pipe for the cooling, and then we've got the pipe for the oil pump to deliver the hot oil to the heat exchanger. There we go. Kind of a transfer tube. You got to be careful taking these hoses off of here so we don't break the aluminum heat exchanger. There we go. And then the heat exchanger itself. So once again, we have two coolant pipes, one from the radiator with cool coolant, goes through, absorbs the heat from the transmission fluid in the heat exchanger, and then goes to the electric water pump, where then it goes up to the inverter converter to cool it, and then back out to the radiator and back here. And then we've got an inlet and an outlet for the automatic transmission fluid on this heat exchanger. These aluminum fittings here can be broken quite easily or pulling on them, so be real careful with what you're doing. All right, we've got a bracket that holds the cooler line on. All right, now we have bolts that hold the bell housing down that are long, and then there are 4 more bolts that are short. You can see right here, these would be the short bolts. These would be the long ones because the case is thicker. We have 5 bolts inside the bell housing that also hold the case half together. All right, let's remove these bolts. For myself, I've learned over the years from damaging threads that if you use an electric gun or impact of any sort and you take these bolts out really fast, that the chances of causing damage are much higher. But if you take them out slowly, to where the air gun hammer is not hammering, then you're not going to damage anything. Sometimes though, these bolts have thread lock on them, and if they have thread lock, if you pull them out really fast with an impact gun, it can and usually does damage threads. So you've got to be real careful with that. It really depends on the type of thread lock, whether it's the low strength or the high strength. And just 2 more bolts right here. All right, the first time you try to split one of these cases, it does not want to come apart. And it doesn't want to come apart for 2 reasons. One is there is a special Toyota form-in-place gasket sealer that makes a gasket between all these metal-to-metal surfaces. It was installed properly out of the factory, which means that both surfaces were clean and dry. All the bolts were dry, the bolt threads were dry. There was no transmission fluid anywhere to contaminate the sealing's ability and adhesion ability of this form in place gasket sealer, or FIPIG as it's called, which means it really likes to stick when you try to separate the two case halves. The other thing is there's usually at least 2 alignment dowels that cause a real tight fit, tight alignment to separate the case halves anyway. So as I've shown in previous videos, Toyota usually gives you some place to pry between to lift up on the case. And so here's a spot right here. You are not to go in and take a hammer and try to wedge this into in between the case halves. You'll damage that sealing surface, and then you've got to attempt to clean that up. So I've already removed the FIPIG. We're just fighting the dowel pins and any bearings that are inside the transmission that are both or inserted into both the bell housing side of the case and the case half, or the center case portion. All right, over here on the other side, there's a place right here where I can pry. And I'll go back over here to our previous pry point. There we go. All right, in this bell housing side, here's where our torque limiting clutch damper was. But on the bell housing side, on the inside of this transaxle, we have several things to look at. First, our ring gear and our differential case sit right here, and it's going to be spinning in this direction, which means it's going to be flinging oil up, and it'll be hitting other gears, and oil will end up getting routed to what are called oil catch tanks. Oil catch tanks. So that's a tank, this is a tank, this is a tank. Here's a tank that has a cover on the front of it to help hold more in, and then it drips out this little hole right here. There's a magnet down here on the other side of this differential oil baffle to gather any metal parts that might, or any magnetic parts that might end up in the bottom of the transmission. You can see we have an input shaft needle bearing in here, and then we have a counter shaft taper bearing cup here with a shim behind it to set the preload of the bearing. Our fluid level check plug is right back here, and at the top of this yellow sticker right here is the approximate fluid level in the transaxle when you've got the proper amount of fluid installed. All right, well, let's set this on its side here. We will take the gears out of this center case half, turn them over, and put them in the bell housing side to really see how this thing works here in a few minutes. But for now, let's take a look at what components we have involved here. Now, when I took the case half apart, a pin fell out that goes to the parking pawl. This is the parking pawl right here, and it will engage with these notches right here on what's called the parking gear. So each one of these notches is a place where this parking pawl can go in and prevent this piece from rotating. So let me just show you it preventing it real quick. I'll slide the parking pawl back in place. I drop the pin. There it is. Alright, so right here is the parking pawl, and notice it's in a notch of this housing right here that we'll talk about in a few minutes, and it's physically preventing that gear from rotating. The shift actuator assembly here on the side of the transmission is what moves some parking linkage up and down inside the transmission and makes that parking pawl engage or disengage from the parking gear. So this only controls whether you're in park or not in park. There is no neutral, there is no reverse mechanically. It's all electrically. The only thing that's done mechanically is park. Even forward is electrical. Okay, so I'm going to remove the parking pawl and its little pivot pin. Okay, let's talk about the rest of the pieces here inside this transaxle. We have our differential case with the ring gear right here. We also have our open style differential that allows the front tires to spin at different speeds as you go around corners. The P610 transaxle right behind the side gear has a beveled plate. That beveled plate preloads the gears to get rid of any backlash that is normally there and is supposed to be there. It also acts just a tiny bit like a real loose limited slip differential. Another thing that's unique about this differential assembly on the P610 is that there are no bolts that hold the ring gear to the differential case. This is a pressed on ring gear. It's pressed on. And notice there are two different differential gear ratios here, depending on whether you have the Prius Prime or the Prius. So the regular Prius, regular Prius has 73 teeth on the ring gear and 21 teeth on the pinion gear that drives it, that's part of our counter-driven gear, that gives us a final drive gear ratio of 3.476 to 1. But if we have the plug-in Prius version, the Prius Prime, then it has 75 teeth instead of 73 on the ring and 19 teeth on the pinion instead of 21, which gives us a 3.947 to 1 gear reduction for the Prius Prime. Now at first I thought, why did they do that? And then I realized that when you are driving in electric only mode, EV mode, you do not have the additional torque of the internal combustion engine to help you accelerate. So I did some math, and let me open that up here. If we go back to the third generation Prius and we look at how much torque the MG2 motor had, the one that propels the vehicle down the road, and then we multiply that through its gear reduction in the motor speed reduction gear set, and then we also multiply that by the final drive ring gear set, we get a theoretical maximum torque of 1,318 pound-feet to the tires. Now, how does that compare to the other Priuses? The first generation Prius was 1,011. The second generation Prius was 1,213. The third generation Prius is 1,318, so 1,300 approximately. And then the Prius only version of the P610 is also 1,301. And the Prius Prime, with this additional gear reduction, gives us 1,477, almost 1,500 pound-feet of torque. Maximum torque. You're not going to have that all the time. That's just maximum combined torque with MG2 propelling the vehicle. Now, I do not believe, no, it doesn't. That does not include any additional torque of MG1 helping to propel the vehicle under those certain conditions. So it would be even higher with that. Now, none of the previous torque ratings I gave you included the torque from the internal combustion engine. So the 1,300 pound-feet of torque that the Prius transaxle by itself to the tires delivers does not include the torque from the engine. So the engine will add another, the engine has another 105 pound-feet of torque that it can deliver to the counter-driven gear that still would go through torque multiplication. So the Prius version, not the Prius Prime, would end up with more to the ground torque than the Prius Prime would. So that's why they had to go with the higher numerical gear ratio on the Prius Prime in the final drive, is to make it accelerate the same way that the regular Prius would with the internal combustion engine. And it's still a little bit lower, but it's good enough that people are happy with it. All right, the next thing to see here on the transaxle is we have 3 gears left. This gear over here is the equivalent of the ring gear of the power split device on the previous transaxles, the hybrid transaxles. These 2 gears over here, this small gear right here is driven by MG2, and it has 17 teeth on the drive gear and 53 teeth on the counter-driven gear, which gives us a 3.118 to 1 gear reduction from MG2 to the counter-driven gear, which turns the final drive pinion gear. So what I'm telling you is these 2 gears right here are the equivalent of the motor speed reduction gear set that was in the P410, the P510, the P310, and all those other P3 series transaxles in a planetary gear set style. So we've gotten rid of a planetary gear set, and all it was doing was giving us gear reduction. This gives us gear reduction also, but MG2 comes in on this side of the counter-driven gear to give torque to the final drive gear that sets right here to propel the vehicle down the road. So that's MG2's contribution. But now the internal combustion engine, which, remember, this is the input shaft. This is where our torque limiting clutch disc splines and connects from the engine and turns at engine speed. So we have the engine over here on the other side that turns one of 3 pieces of the power split device planetary gear set. We'll look at those here in a moment, but it's still the planet carrier, just like in every previous Prius transaxle design. And then MG1, the electric motor, down below in the case here, turns the sun gear, and then the ring gear is just simply inside of this housing. So this is very much like the big counter drive gear from the P410, 510, and the P300 series transaxles. We've got the counter drive gear on the outside. We have on this one a single internal gear or ring gear for our planet carrier to rotate inside of. So that's our engine rotating that. It sits on 2 great big bearings that sit inside of the transmission housing right here. And then our counter drive gear is just right here. You can see we have tapered roller bearings that need to be preloaded with the shims that we talked about before. And then our last gear right here is connected to MG2. So this is MG2 spinning down in the case. This over here is MG1 spinning down in the case. MG1, MG2, they both can contribute torque to the counter-driven gear and the final drive. All right, now this transaxle uses some sealed, not really sealed, but it uses bearings that have O-rings on the outside of them. And that forces any lubricant to go through the bearing, the ball bearing, these are ball bearings, rather than sneak out around the outside of the bearing cup. Now, where have we seen that before? First generation Prius had the same design, except it was just a single O-ring rather than a dual O-ring. We've got a sealed O-ring style bearing on the inside of this drive sprocket support. There's a sealed bearing right there with the O-ring. We've got it on both sides of this drive gear for MG2. And those O-rings make it a little tight to get the assembly out of the case because they're squished in there. Make sure that you lubricate those very well before you put this back in, otherwise you'll cut them. But this is the drive gear that MG2 rotates. As you can see, it has splines right here that are going to connect to the MG2 rotor. It has a seal right here of some sort. I don't know if it's a lubricant or cooling lubricant seal or something for NVH reduction. I'm not sure. I've never seen something like that in the previous transaxle. Okay, over here the sun gear that MG1 rotates actually is splined on to MG1 along with the bearing race down in the case. So we've got a sun gear that splines onto the end of MG1 rotor when we get that out here in a few minutes. Okay, you can see right here in the case we have an oil pump pickup tube and screen assembly. So I'm going to remove that. It has an O-ring that slides right into the oil pump on the back cover of this transaxle. All right, then we've got the park linkage and the rest of the parking pawl and the detent over here. We'll take those out a little bit later. We have a cooling pipe right here. So our banjo bolt and that hose from the heat exchanger come in right here, goes into this pipe, comes up and cools MG2's stator. It goes through the case here and cools MG1's stator as well. And you can see, just like we talked about on the other case half, the final drive will be spinning, let's see, it'll be spinning this direction. That's the front of the vehicle. The final drive turns the same speed and direction as the tire, so it flings oil up into these oil catch tanks where it drips down through different holes to lubricate bearings and so on. What they're trying to do here is reduce the use of an oil pump and use this oil slinging method to get as much lubrication and cooling done as possible to try to be more efficient. Especially on the Prius Prime, the plug-in Prius, it actually has an external electric oil pump that will come on as necessary to provide cooling and lubricant. All right, let's take off the three-phase cables and connections right here on the side of the transmission. So you can see all 6 three-phase cables right there and how little tiny they are. This system only runs on 600 volts maximum rather than the 650 that the previous third generation Prius ran on. These cables are of course extremely short, so there's lower voltage drop, lower power loss. They connect, I already showed you, directly to the inverter converter that sits on top here, and then they have this same type of connection where it bolts into the transaxle and the three-phase cable connections to the stators right below it. So we have a protective shield that comes off first. That protects the plastic components, I believe, from heat and any type of physical damage. Then we have a weather seal that goes across the top here. This weather seal you got to be real careful with. It has a clip, and of course it's plastic, so it'll break if you look at it wrong. Undo both sides very carefully. Here we go. So there's our weather seal. Once again, keep all this stuff separated. These electrical connectors and connections need to be clean and dry. And now you can see the 6 bolts that hold the three-phase cables to the pass-through connector right here in the case. Let me break all those loose and get them out of there. All right, so now this whole connection can come off. Just like that. The rest of this stays on for a few more minutes. We cannot remove it because it is physically connected with some bolts to the MG1 stator and the MG2 stator down inside the transaxle. Get this stuff out of the way. We also have a pass-through connector here for both temperature sensors that are in the transaxle, one for each stator, and that's part of this pass-through connector. We also have the transmission vent right up here on the top of the transaxle. Okay, before we turn this over and work on the other side of this transaxle, the Toyota service information typically tells us to use some blocks of wood to lay the transaxle on so that we're not denting any pipes or park linkage or springs or anything else here on the side of the case. My experience with blocks of wood is they like to slide out of place and leave splinters of wood where they shouldn't, and so I figured out to put just put some of the case half bolts back in it and let them extend up high enough that it's not going to interfere or allow any rubbing to take place on any parts that can be damaged. So I'll just stick a few bolts in there. Okay, just like that. All right, so we're ready to turn this case over and work on the other side. The heavy part of the case is in the top because the motors and the stators are in the top of the case. So I'm going to very carefully tip it up and around and back down. I forgot to remove the oil pump drive shaft, so it just fell out. I'll show you where that goes here in a moment. but it is driven off of the planetary carrier on the power split device off of the engine, just like all the other transaxles. All right, we've got a lot of bolts going around that hold this side cover on the transmission case. To remove one of the bolts, we have to remove one of the cooler fitting lines here, fitting adapter lines. It just has an O-ring that does the sealing of the threads. So we'll take that out, set it off to the side here for a moment. Now we'll come in and remove these bolts. "21 bolts. They all had no, they didn't have any Loctite, any thread lock on them. It was just a little bit of the fippig on the tip of them that was there. All right, this side cover, of course, is held on with the same Toyota fippig material. There should be some pry points. Here's one right here that's quite obvious. There's another one right here. There's one right here. There's another one right here. Another one right there. They're all over the place if you look for them. I'll just keep that from falling out. Once again, be careful you don't pry somewhere you don't, or where you shouldn't. That might cause some damage to the sealing surface. Pry on the alignment dowel area. They typically do not put sealant on the outside edge of the alignment dowels, so you're safe to pry in that area. There's another alignment dowel right here. Now we've got stator windings just inside here, so you don't want to be sticking a pry bar deep inside and trying to pry on whatever you can find. There we go. Okay, so we've got our side cover right here. Just here on the inside of the side cover, we have the MG2 resolver assembly that measures the rotational speed, direction, and position of the MG2 rotor. We have the MG1 resolver, same thing on it. The MG1 resolver and resolver rotor that it goes with is a high resolution one on this model. I'll show you that here in a moment. Here's our oil pump assembly on the inside of this case now, and then our pickup tube for our oil screen went in right there. We've got a temperature sensor coming in right here, and then an electrical connector right out here for both resolvers and the temperature sensor for the fluid. So that means we have 3 temperature sensors in this transaxle. The fluid temperature here for the output to the cooler. And then we have 2 temperature sensors, 2 more, one for each stator assembly. All right, we'll come back to the side cover here in a few minutes. Let's look at the case. As you can see here in the center case area with the side cover removed, we have the MG1 rotor and the MG2 rotor. Now neither of these will rotate at this time because they're full of very strong magnets and they're sticking to the stator assembly because we removed the supports by removing that side cover that hold them centered inside of the stator. So don't try to rotate them, and don't think something's wrong with them if they won't rotate. You've got to take them out as an assembly if you're going to change one. We have MG1 temperature sensor right here, MG2 temperature sensor and electrical connector right there. We have just a beautiful MG2 stator assembly here. Toyota calls it a segmented winding, where segments of a special conductive copper alloy are welded together rather than little tiny windings of wire in one continuous loop like on the previous stator assemblies. All right, so to remove these rotors and stator assemblies, like I said, we got to take them out as an assembly. I've seen videos on YouTube of other people disassembling hybrid transaxles, and they're in here with big pry bars prying on the resolver rotor and smashing the windings of the stator. You don't need to do that. You let gravity do the work for you. All you do is loosen the bolts and turn it over and lift the case off of them, and they'll come right out. All right, so I'm going to tip this up on its side and take the bolts out, and then take the stators out myself, just sitting right here. You can see here in the back of the case we've got the 6 bolts that bolt the stator windings with 3 wires each to the pass-through connector on the top of the transaxle. Before we remove the stator assemblies, we've got to unbolt them from the pass-through connector, and of course we need to undo the temperature sensors and get them out of the way also. So we've got the MG2 temperature sensor right here. It just unplugs just like that. The MG1 temperature sensor is right here. It bolts to the case and sticks inside of the MG1 stator. Just like that. There's a hole right there where the temperature sensor plugs into. So the temperature sensor right here just plugs into that hole to measure the temperature of the stator. Now there's this little rubber piece right here that falls off, and if you didn't notice it and it falls off and you lose it, you'll be in trouble. That plugs on right to the end of this drip tube right here, and I'll show you that in more detail here in a moment. But when you take this side cover off, chances are that little rubber plug is going to, not plug, but this little rubber piece is going to fall off and you'll lose it. So hang on to that. There's an electrical connection right up here for the pass-through of the temperature sensor, just like that. And then this electrical connector right here just has a slide-off clip that holds it to the little drip tube for the MG1 cooling. Put that little rubber plug in the bag here with the with the rest of the stuff here from the stators. Going to undo all 6 bolts here next. You should not use an impact gun on stator connections. The little pass-through pieces are plastic. They harden up over time and they will break if you use any type of an impact on them. So be careful. Just use a little hand wrench or little socket. 1/4 inch drive is what I use on these things. Take them off by hand. Put those all in the same bag. Now I need to show you the resolver rotors. So remember, the resolvers that I showed you in the side case track the speed, position, and direction of rotation of the rotors themselves. But what's happened here on this new design P610 Transaxle, notice the rotor has 5 cam lobes on it now instead of the 2 that we used to have. It has 5, which I believe gives better resolution. Now if we look over at the MG2 rotor, right there, it only has the regular 2 that it's always had. So I do not know why one has 2 of them and the other one has 5. Maybe they need the 5 lobe one for the Prius Prime version, where they use MG1 to help propel the vehicle also. I just don't know. I haven't been able to find anything describing that in the service information or any SAE documents or patents. I haven't found it yet. I'm sure it's there. I've just missed it. So if any of you know, put a comment in the box below there and let me know. All right, so we are ready to remove these stators. They have only 3 bolts each. Let's take this upper one out first. Like I say, I've had this apart before. I did not retorque all these bolts. If you do any work on aluminum housed transmissions, you'll find that over time you can only torque bolts so many times before those aluminum threads give out. So I'm gonna wait until I have to put this back together, because this transaxle actually has to work. It's got to go back in the vehicle. I took this out of a brand new 2017 Prius Eco. It's over here on my hoist. I took it out just to do this video. I wanted to see what the new transaxle design was and if it was the same as the Ford ones of past and so on. And like I said, it's similar to the Ford ones of the past, and also similar to the new Chrysler Pacifica plug-in hybrid van transaxle, but there are some differences too. All right, let's remove the stator and rotor assembly. The rotor assembly is still in the bearing that holds it in place on the other side that keeps it centered. But there's the bearing that holds it in place on this side is in the side cover and removed. So the rotor's kind of tilted off to the side a little bit. And so to get the stator and rotor out as one assembly, I'm going to have to come in on the back of the transaxle here. And just tap lightly on the back side of the rotor. The MG1 rotor splined hub right there. And the MG2 splined hub is right down here. So I'm not going to hit it really hard. I'm using a rubber hammer, but I'm just going to tap like that. I felt it come loose. So we'll go back to the other side. And this whole assembly now can lift right out. Now whenever you take a stator assembly out of a transaxle like this, you need to lay it on the stator frame. Do not lay it down sideways where you could damage the stator windings or this resin type material that helps keep the stator windings cool. You can see the rotor is inside of that. I'll show you how I get that out here in just a few minutes. But let's get the MG2 stator out next. So I'm going to come in on the back side with my rubber hammer and just knock it out of the bearing just a little bit. Oh, I guess it would help to take the three stator bolts out. John, I thought, why is that not coming? While we're here, right here is a stator drip pipe for cooling that we'll take out before we remove the stator here on the MG2. So this tube right here drips fluid down onto the stator windings. It's fed fluid from the oil pump after it's gone through that heat exchanger and then through that long pipe I showed you into here, and then there's little holes in here where it just drips down onto the MG2 stator. This, by the way, is the prettiest stator I've ever seen. The color of the wiring, just the winding of the stator itself is just a beautiful stator. Makes me wonder if the rest of them look that way when they're brand new and then they just oxidize over time. Okay, so we're ready to take out MG2 stator. Now that we've got the bolts undone, let me finish tapping the MG1 rotor or MG2 rotor out of the bearing. All right, it needs just a little bit more assistance from the other side. I'm going to come in with a brass drift and just tap. My hammer can't get to the, my rubber hammer can't get to the surface I need to tap on. So I'll just tap it. Here we go. With this brass drift. Now it's free. And you can see the entire stator assembly is starting to move forward, so we'll just slide it forward, keeping an upward lift on it so we don't damage any of the laminations. And there we go. So here's our MG2 rotor and stator assembly and the three wires that go to our pass-through connector. So let me set that out of the way for a moment. Now what's left here in the case is another drip tube, just like that other one I showed you. And remember that those drip tubes get fed by the fluid coming from the heat exchanger through this pipe and through to this plastic one I already showed you, the drip tube for MG2, and through the case on the other side for MG1 for cooling. So I need to next, before I can get that drip tube off, I need to remove the the three-phase pass-through connector. And here comes the whole pass-through connector assembly right there. And then the very last piece to remove on this side is our drip tube that provides cooling for MG1. So right there. All right, so we've got everything on this case disassembled except the vent. I'm not going to take that out. And this transfer pipe right here, I could take it out, but there's no reason to take it out at this point. If I was overhauling this transmission, I would certainly take that out and clean it. And I would disassemble the parking linkage and make sure that it's not worn out and clean it too. But it's the same parking linkage as every other Prius Transaxle up to this point. The same components, so I'm not going to take that out either. All right, so we are done with the center case. So let me get that out of the way. Okay, the next step is to remove the rotors from the stators. Why? Well, just because I want to take a look at it. These rotors have been updated since the previous Prius Transaxle, the P410, and I want to show you how they've been updated and their configuration, and look at their power ratings and torque ratings and so on. So to get those out, because they're held in place quite tightly with permanent magnets, I use some sort of a foam pad. So this is just a snap-on kneeling pad to kneel down if you're working under the dash of a car and your knees hurt on concrete. I'm going to use that as a pad to catch the stator assembly when I push it out. Now, the stator assembly has the resolver rotor side, and we do not want to push on that side. And then it has the other side with the splines that hook to the sun gear, and has a big nut here, and I'm going to use that side. What I do to remove the rotor is I just get a big socket, and I don't use the socket to undo anything here. I just use it as a pedestal. I just use it as a pedestal to lift up the whole assembly, just like this. And then I'll just come in and push down just like that, and there's our rotor. Now I put some labels on it. I wasn't sure if they would clear the the stator with it installed, but apparently they did. So it's got a little bit of an air gap there. But you see, I did not do anything to damage the rotor. This is the MG1 rotor. I'm just going to set it right over here for the moment. The stator itself, when it came down, it landed on this foam pad, which didn't damage anything. And so now when I set it back on the hard table, I'll set it on its stator frame with the 3-phase cables sticking up so that it won't roll over and damage them. And then we'll do the same thing here on the MG2 rotor and stator assembly. On a deeper one like this, sometimes I have to use a extension to lift it up higher. Just the weight of the stator assembly almost takes the rotor out by itself. On this model, some of the previous ones had much stronger magnets in the rotor, but this one's fairly weak, relatively speaking. So now I'm just going to push down just like that, and that's all I've done on the other ones. It took me and another person to do it. I don't have that much strength. One of you guys could probably do it yourself, pushing down, but if you don't have something soft for it to land on there, your chances are you're going to damage the windings, as we've talked about. So here's our MG2 rotor, and I'm going to set it away from MG1 and away from anything magnetic, because everything will stick to it, and it could possibly damage the possibly damage the rotor also. So now I'll tip this back up and set it over here out of the way. So that's our stator. Isn't that beautiful? Right there, that is a pretty stator. You can see where the segments were welded over here rather than a continuous winding like the small round copper wire stators of the past. As a matter of fact, one of the things that they're bragging about on this transaxle is they use less copper, they use less permanent magnets, that use rare earth materials to make the rotors themselves. So a more lightweight, more efficient design. All right, our next step is to disassemble this side cover with the oil pump and the resolvers. Now these resolvers have a dowel pin in them. See that dowel pin right there? That dowel pin aligns the resolver with the case, and you cannot get it out of adjustment as long as you're paying attention. You really could put it in several different, actually 3 different orientations if you're not paying attention, but there's a black plastic tab right there that should point at the alignment dowel. Now each of these resolvers is marked differently. It's a different part number. This one right here actually says MG2 right on the top of it. This one of course says MG1 because that's what they're for. Okay, we have a wire harness right here that goes through to an external connector. I'm going to take the bolt out of the external connector. The bolt that holds the temperature sensor and the wire harness bracket in place, and get those out of there. This bracket keeps the wire harness away from all the rotating parts and the hot parts. And then the electrical connector just unplugs out of each resolver. The temperature sensor unplugs and sticks out the side of the side case here where it has a little connector that unplugs also. So then we've got the wire harness and the electrical connector that it goes with. I'll just hook those 2 back together and we'll bag all that up. Get it out of the way. Okay, next we've got the 2 resolvers. Their bolts are the same, but the resolvers are different because of the positions that they fit in. So if you look at the resolvers here, you'll see there's a dark plastic tab that points right here on the MG1 resolver, and that plastic tab points over here on the MG2 resolver. Those tabs point to the location where the dowel pin, here's a dowel pin and here's a dowel pin, should line up. Now if I take the MG2 resolver, I can take it out of alignment like that. It's almost not quite 180 degrees out of alignment, but of course the wire harness would not plug into it, so that'd be difficult. That's the right way, and no, I guess it only goes on the one way if you want the wire harness to plug in. So that's, somebody was thinking there with the past transaxles and how all that could get messed up if somebody accidentally took those resolver bolts out. All right, the last part that's in the case here is the oil pump assembly. So it has several bolts that hold it to the side cover. Looks like 9 bolts. And then this pump has some alignment dowels that hold it in alignment with the side cover itself. And so it's not going to just fall off or come off easily on the case here, or the side case. So there's a couple of pry points. There's a dowel pin here and a dowel pin here. We've got to come in and lift up at the pry point, around the pry point areas, without damaging the surface that it just about there. There we go. Okay, so here's our oil pump assembly. You can see the Trochoid pump gears in the back here, and then of course you can see some of the case passages here in the front. Now if this was the Prius Prime plug-in Prius, it would have some additional fittings out here on the side case for the electric oil pump that is used when the internal combustion engine is not being used while you're in EV mode. Now this oil pump comes apart even farther, and it has some little spring-loaded pressure regulator valves inside of it, 2 of them. One of them is the standard overpressure valve that all Prius transaxles have, where if the fluid pressure gets too high, this valve will open up and just dump the excessive pressurized fluid into the case. The other valve that's new to this one, and there's a plate here I'm taking off. I've got to hold down against the spring pressure of these 2 valves when I take this bolt out. The other spring-loaded valve is a cooler bypass valve. So if the cooler, that heat exchanger on the front of the transaxle that we took off, if that were to get restricted or plugged, or any of the pipes get plugged like that, then the second valve would open up and allow the fluid to go to the bottom of the case inside the transaxle and just bypass the cooler at that point. Now, if that happened, then eventually the transaxle could overheat and it would trigger a trouble code and maybe a master warning light and so on. Now, on these 2 valves, the valves themselves look identical. These are the 2 spring-loaded valves I was telling you about. This is the pressure relief valve. If the oil pump pressure gets too high, this is the cooler bypass valve. If we lift those 2 valves up, there's springs underneath them. Notice this one is painted white and this one is not painted. The one that's painted white has a lower spring rate than the one that's not painted. In other words, the cooler bypass valve will open before the overpressure valve will open, and that makes sense. So we've got those 2 springs. And then the last part here is the Trochoid pump itself. And I want to show you how big this pump is. The pump gears. They're huge. So let me set this here on the bench. There's the Trochoid pump out of this P610 transaxle. Now let me grab the other two trochoid pumps, one from the P510, one from the P410. So here's the P510 trochoid pump, which is in the Prius C, and here is first, second, and third generation Prius oil pumps right there. So they all have the same diameter, but obviously they're different thicknesses. The different pump thicknesses will result in a different volume of fluid being moved. And this one for the P610 is not quite twice as thick as the one for the P510, but it's close to twice as thick, which means we're moving a lot of fluid in this transaxle, and I'm sure that's for keeping those stators cool. Besides lubrication, but keeping the stators cool and the rotors cool is an important thing. All right, so that is the oil pump assembly. Oh, by the way, there's some dimples or dots on the gears here. Those go down in the housing. There's a lip that has a recessed bore on the inside pump gear here that if you don't get that lined up, it won't fit in place. All right, so we'll get our oil pump assembly out of the way. All right, we're ready to put all the gears into the bell housing portion of the case where we can see everything interact together with both the MG2 and the MG1 rotors and everything else. So the first thing that needs to go in here is the power split device planetary gear set, which in this big housing here contains the planet carrier that hooks to our clutch damper assembly. Now for this demonstration, I'm going to remove the planet carrier from this counter drive gear assembly so that we can have the two pieces together separately. To do that, I need to remove one of these bearings, so let me press that out real quick. Okay, so I pressed out the bearing that's on the parking gear side of this counter drive gear housing, and now you can see down inside here is the internal gear or ring gear of the planet carrier for the power split device. The planet carrier connects to the engine through the clutch damper assembly. So that is just like the P410, just like the P112, just like the P111, just like the P510, all of the others. The power split device has not changed in all 20 years of the Prius transaxle operation. They all have the exact same number of gear teeth. They all have the exact same gear ratio on the power split device. Okay, so on this front bearing here, there is an O-ring that if I don't remove that O-ring, it'll fight me putting this on. And since I need this O-ring to seal when I go back together for real, I'm going to take that out and keep it in good shape off to the side here. So now the counter drive gear that has 65 teeth will slide into the bell housing side of the transmission case. It's a tight fit. It's not a press fit, but it is a tight fit. There we go. Those tight fits, they always fight you. But don't hit down on it or you'll run a pretty good chance of causing bearing brittling. All right, so This is the ring gear of our power split device. Here's our planet carrier that connects to the clutch damper assembly. There is a bearing that goes on here and a spacer. And then it just lines up with the planet. Lines up the planet gears with the internal ring gear. So the internal ring gear and the external counter drive gear are in the same housing. They turn at the same speed, but they have different number of gear teeth. All right, the next thing that would go on to our power split device, as in any other Toyota Prius transaxle, is the sun gear. So we've got the sun gear of our planetary gear set. So any planetary gear set has three components. The sun gear, which connects to our MG1 motor generator, starts the engine and also generates power to recharge the battery and to send power to MG2. We've got the planet carrier that I just installed that hooks to the internal combustion engine, or ICE. And then we have the internal gear, the ring gear here, that is connected to the same housing as our counter drive gear. So I'm going to put, and it has a bearing on it, the sun gear down into the planet carrier. And then I'm going to take our MG1 rotor and line it up and set it down into the sun gear, just like that. And then our oil pump drive shaft that turns that great big high volume pump goes down through the middle of that and connects to the planet carrier. And so this drive shaft will turn the same speed as the internal combustion engine. All right, so here is our MG1 rotor. The MG1 rotor is rated at 23 kilowatt, which is 31 horsepower. It also has 40 Newton meters of torque, or 30 foot-pound of torque maximum. And that is used, we only use that torque on the Prius Prime when we use MG1 to help propel the vehicle under certain conditions. All right, the next thing that we install is the MG2 Drive gear. The MG2 Drive gear here. The MG2 Drive gear, of course, has MG2 Stator connect to it. Now remember, these have the ball bearings and the spacers that position it in the case, and probably preload the bearings too. But this one has the O-rings on it, so we need to take the O-ring off for this demonstration so that I don't ruin it. So it has two brown colored O-rings. The reason I'm taking those off for this demonstration is they interfere with putting the gear and bearing assembly down into the case for this demonstration. So we've got our spacer. I'm sure that is a selective spacer. And then our MG2 MG2 driven gear, the MG2 drives it, goes down in the case next. And of course MG2 then comes along and splines into the top of it. And MG2 is rated at 53 kilowatt, 71 horsepower, 163 Newton meters of torque, which is the same as 120 foot-pound of torque. And both of these motors have less power in the motor themselves than any of the previous Priuses out there. But what we do to get more torque out of them is to use gear reduction. Anytime you go through a gear reduction, you also get a torque multiplication. And so we end up having more torque, as I lightly explained earlier, by going through gear reduction than any of the previous Prius transaxles. Okay, the next part that goes in is our counter-driven gear. The counter-driven gear has teeth on it right here that will spline to the MG2 driven gear and also to the MG1 power split device counter drive gear. So there's this, what I'm saying is this gear receives torque from two different locations. MG2 gives it torque, MG1 in combination with the internal combustion engine gives it torque on the regular Priuses, and then the Prius Prime, Prius plug-in, MG1 itself can add additional torque without the internal combustion engine. So we will set that in here next. Whoops. Just like that. So now we can see on the previous, all the previous Prius transaxles, anytime you rotated MG2, it always rotated the ring gear or internal gear right here of the power split device. And notice now, I'll hold MG1 from rotating. If I turn MG2, this ring gear rotates. So it's exactly like the previous transaxles, but it's just accomplished differently through this parallel axis transaxle design rather than the inline axis where we had MG2 over here on top of MG1 with another motor speed reduction planetary gear set in between them. Well, the motor speed reduction planetary gear set is out, but we still have motor speed reduction going on through the counter-driven gear, the MG2 drive gear, and the counter drive gear over here. And then, of course, our last piece to come in is our final drive assembly. Just like that. So on all previous Toyota transaxles, if MG2 rotated at all, so did the final drive, which connects to your CV half shafts, which connect to your hub and bearing assembly and your wheels and your tires. They all turn the same speed as this. But we've got a huge gear reduction going on now here in the P610. So in order to move the vehicle forward one rotation of the tire, if you have the Prius, it's going to take 10.838 rotations of MG2 to get one rotation of the tire. And it's going to take 12.3 rotations of MG2 on the Prius Prime, Prius plug-in to get one rotation of the tire. Now, how does that compare to previous? Just the previous model, the P410. The P410 was 8.6 rotations. The P410 was only 8.6 revolutions. But the P410 had higher horsepower, higher torque. It had 60 kilowatts instead of the 53 that we have here. And so it could handle a lower numerical gear ratio and still accelerate well. Now, since we've gone to lighter weight, smaller rotors for both MG1 and MG2, they need to spin at higher RPM to have the torque and horsepower that they need. And so they have stepped up the maximum rotational speed of both of these gears, or both of these rotors, to 17,000 RPM, which is incredible. The P410 was at 13,500. The P112 in the second generation Prius was at 10,000. And then the first generation Prius was at 6,500. But what they've done over the years since the first generation Prius is that, well, the first generation Prius had a huge rotor with a lot of torque. It was 259 pound-feet of torque, I believe, and we've only got 120 here. But it had a gear ratio that wasn't very good. It was turning like 4 point, let me find it here. No, the first generation Prius took 3.9 revolutions of MG2 to get one rotation of the tire. And then the second generation went up to 4.1. And then the third generation went to 8.615. And now we're clear up to 10.8 for the Prius and 12.3 for the Prius Prime and Prius plug-in. So faster and faster rotor speeds, less power of the rotors themselves, but through the gear reduction and torque multiplication, we actually end up with more torque at the wheels than we've had in any of the previous designs. So high-speed rotors. I want to show you something they've done with the rotors. Toyota published in the SAE, Society of Automotive Engineers, a paper called Development of a New Hybrid Transaxle for Compact Class Vehicles. And in this document, it tells us several things about this transaxle, about how they've reduced its weight, and it's a new parallel design. It's 47 millimeters less in width. Its weight has been reduced by 20%. They used less rare earth materials and magnets. The volume of magnet used was reduced by 15% compared to the P410. They used segmented windings in the rotors, or in the stators, which reduced their weight by 21%. They help reduce copper loss also. And then about the rotors themselves, and I quote here from the document, a new high-speed, low-loss rotor was developed to support the high-speed rotor. A lock nut method was adopted to tighten the core. So if we look at the bottom of these rotors, you can see a great big nut here on the back of them. We didn't have the great big nut there before. That's something that the Ford transaxles used. And then with that nut tightening the core of all these laminations, there's also no great big thick clamping plate on the top or the bottom. We are just right to the laminations themselves. And if you look closely, you can see the little V grooves that the magnets, here's a V right there, the V-shaped magnets to give it 50% more strength than the flat first generation Prius design rotor, so it's a more powerful rotor. It goes on in this document, and I quote, furthermore, a magnetic circuit design was developed that improved the reluctance torque of the rotor core. This improvement was made possible by motor size reduction achieved through measures such as increased rotational speed. As a result, the volume of magnet used was reduced by 15% compared to the P410. Now, an interesting thing on the MG2 rotor. Now, before I show you this, the first generation Prius MG2 rotor just used the flat bar magnets in or aligned around the outside of the rotor there. The second generation Prius went to the V configuration magnets, and if you're not sure what I'm talking about, go look at the P112 deep dive video that I made. I'll show you. It actually shows you the configuration there. Well, the third generation Prius continued that V shape, but this fourth generation one looks different, even from that. Now, I found nothing in publications to prove this, but let me show you what I'm talking about here. So if you look at the little notches, these little notches in the top cover here of the rotor, you'll see, like right here, there's one pointing in this angle, that's a magnet. There's another one pointing at this angle, that's a magnet. So there's the V configuration right there, like we've had since the second generation Prius. But there's also a flat bar magnet that goes across this way. There's 3 magnets there, from what I can tell. I can run my screwdriver across it and I can feel the polarity change across those 3 magnets. And then there's these 2 little, what appear to be little tiny magnets in the back there. So it almost looks like there's 5 magnets, unless those 2 in the back are just continuations of the 2 that are V-shaped anyway. So at bare minimum, there's at least 3 magnets in this rotor shape. If any of you know what the configuration is there, I don't know why I like to know stuff like that, but I think it's cool to find out the inner workings of these things. Okay, so we've got all of the components here. Now let's just go through the power flow, see how this thing transfers power in the different modes, and we will be done with this amazing P610 transaxle. Okay, so as you're driving down the road in electric vehicle mode, with the engine off, the planet carrier, the internal combustion engine, is off, and there's a gear ratio from MG2 to MG1 of 1.199 or 1.2 to 1, which means MG2 will spin 1.2 turns for every 1 turn of MG1, which is kind of unusual because in the past MG1 has usually spun faster than MG2, but in this case it's not. So let me hold the input shaft from rotating. I will turn MG2 1 and a little bit more, 1.2 turns, 1 1/4 turns approximately, to get 1 rotation of MG1. All right. That keeps MG1 from over revving, even though we have a maximum speed of 17,000 RPM. So that means that MG2, through the counter-driven gear, is driving the final drive. It's also turning MG1 and having it either generate power or just kind of sit there in a low power mode, almost totally off. I know it says off, but it's got to be generating just a tiny bit of power. You can't spin a magnet inside a coil of wire without producing some voltage. So in electric vehicle mode now, if we want motor generator 1, like on the Prius Prime Prius plug-in, to help MG2 through the counter-driven gear propel the vehicle with the final drive gear here, we need to power up MG1 and have it rotate in this direction. But you'll notice if I turn MG1 in this direction, the ring gear is not moving. There's no power being transferred. And let me remove the MG1 so you can see what's going on here. I'll zoom in. Okay, so this sun gear right here is connected to MG1. So if I rotate this sun gear, that's the same as turning the MG1 rotor. So notice as I turn this sun gear, the planet carrier right below it is spinning. Now that planet carrier connects to the clutch damper, flywheel, and the engine crankshaft. Well, that just happens to be in the opposite direction. That's a reverse rotation of the engine. Well, we don't want that to happen because that doesn't allow any torque to be transferred to the final drive ring gear. We want MG1 to help MG2 propel the vehicle down the road. So if we could stop the planet carrier from rotating, so now I'm going to hold it with my finger and keep it from rotating. I'm still going to turn the sun gear. Notice now everything rotates and we are supplying power to the final drive through the MG1 rotor. So we have to stop the planetary carrier, which is hooked to our flywheel and clutch damper assembly, and that's why the Prius Prime has this one-way sprag clutch assembly. This one-way sprag clutch assembly has some spring-loaded sprags that at the higher speeds they will fling out and not be dragging like a ratchet would as you rotate a ratchet here. That ratcheting noise is little sprag teeth inside that are spring loaded, clicking on some little teeth. But if we turn it in the opposite direction, then it locks up. If we were to hold the shaft or the socket from turning, we can't turn the ratchet. That's the same idea as we're using with the flywheel and the one-way sprag. So as we start spinning MG1 in the direction we want it to spin to help propel the vehicle, that will cause the flywheel to change directions. And as it changes directions, it'll stop spinning in the one direction. It has to come to a complete stop and then start spinning the other direction. At that one point where it stops to change the directions is where those spring-loaded sprag teeth will come down and engage and lock it into place. And then MG1 can help propel the vehicle down the road. It's a neat system. Now that is not unique to Toyota. If we go clear back to the 2005 Ford Escape, it has a one-way sprag on its planet carrier. The 2017 Chrysler Pacifica minivan with the SI-EVT transaxle has a one-way sprag on its input planet carrier. So all three, the Ford design, the Chrysler design, the Toyota design, have used this sprag method. Now, interestingly enough, the later model Fords, the second and third generation Ford Transaxles got rid of that. And I'm not sure it was really used in the first generation one, but it's there. I'll show you a picture here on my first generation Ford hybrid transaxle over there. Now, like on any of the previous hybrid transaxles that went in the Prius or any other Toyota hybrid, we can contribute up to 100% of the engine torque to help MG2 propel the vehicle down the road. Now, how is that accomplished? It's accomplished through the power split device planetary gear set. So we've got three pieces of the planetary gear set. We've got MG1 that turns the sun gear of the planetary gear set. We've got the engine that turns the planet carrier. And then we have the internal gear or ring gear that is connected to MG2 and to the final drive. And so a neat thing about planetary gear sets is if you force any two of the three components, it doesn't matter which two, if you force any of those two components to turn the same speed, all three pieces will turn the same speed, which means there is a engine RPM for a specific vehicle speed where the MG1 rotor speed, which is the sun gear, will match the engine RPM that drives the planet carrier. Now, I did some math for this vehicle here. the 2017 Prius with the P610 Transaxle, if you're driving 65 miles an hour down the road, you will get 100% engine torque with an engine RPM of 3,240. So at engine RPM of 3,240, the MG1 rotor speed is also 3,240. So that's the carrier and the sun spinning the same speed, which locks all three pieces together here on the power split device, and all of the engine torque can be transferred into the final drive, helping MG2 propel the vehicle down the road. Now, there's also another speed, engine RPM, where MG1 totally stops. And that is, if you're doing the same 65 miles an hour, it's just 900 RPM lower at 2,340 RPM. So at 2,340 engine RPM, that's spinning the planet carrier at 2340. The ring gear, the internal gear, will be spinning in the opposite direction, and at that same time, MG1 just sits there. We're not electrically stopping it from rotating. It's just that that's how it works out with the planetary gear set. So, kind of interesting. If it's totally stopped, obviously it's not generating any power, and that might be useful if your battery is full and you don't need additional power to help MG2 drive the vehicle down the road. You just simply turn off the generator by quit having it rotate. And then we can speed it up or slow it down faster than engine RPM or slower than engine RPM just by changing the engine RPM. So we can run it up to its maximum RPM, positive or negative, to generate current, no matter if we're in a positive or negative torque situation. Very interesting, a very neat design. And like I said, every Prius, every Toyota hybrid transaxle uses that same power split device to act as a continuously variable transmission in regard to the engine RPM. Toyota calls it an eCVT, an electronic continuously variable transmission. So MG2 has nothing to do with being continuously variable. It's a traction motor that is directly geared to the final drive. If you turn MG2, you're going to move the vehicle down the road. But the continuously variable portion, or infinitely variable, if you want to call it that, is the speed of MG1 versus the engine. All right, well, I've had a good time disassembling this transaxle and getting to know it. It's definitely different than what we're used to as far as Toyota transaxles, but I get the feeling we'll see bigger versions of this neat transaxle in the future. Thank you for watching.